National Electrical Code (NEC) Section 338.12 addresses grounding and bonding of electrical equipment. Specifically, subsection D, focusing on service cables, states firstly, a bonding jumper shall be used to connect the grounded service conductor to the grounding electrode system of the service equipment, and secondly, the equipment grounding conductor shall be bonded to the grounded service conductor at any point on the premises. This code section necessitates the grounding conductor to be bonded to the grounded service conductor either at the service equipment or at any location on the property. Enclosing a rope service, especially when the weatherhead protrudes and is subsequently covered by siding, obstructs the proper bonding of the grounding conductor. This obstruction can lead to a compromised electrical system and introduce potential safety risks. Consider the potential consequences if siding is installed over a rope service with an exposed weatherhead. One potential consequence is a loss of grounding. Siding can electrically isolate the grounding conductor from the grounded service conductor, which results in a loss of grounding protection for the entire electrical system. Another is an increased risk of electrical shock. Without appropriate grounding, electrical current may seek alternative pathways, such as through the siding itself, which elevates the potential for electrical shock. Finally, there is fire hazard. A compromised grounding system can cause electrical faults to remain undetected. This lack of detection can escalate into arcing and potentially trigger a fire. Though an electrician might not be responsible for the initial installation of a rope service in a problematic manner, their professional responsibility extends to ensuring the safety and code compliance of the electrical service. An electrician should bring the issue to the attention of the homeowner and recommend modifications to the siding to accommodate the weatherhead. This accommodation ensures appropriate bonding and it ensures safe and reliable electrical service. Focusing on the specifics of Section 338.12, it's important to dissect the implications of the grounding and bonding requirements for service cables. The purpose of the bonding jumper connecting the grounded service conductor to the grounding electrode system is to create a low impedance path for fault current. This path facilitates the operation of overcurrent protection devices, like circuit breakers, which are designed to interrupt the circuit in the event of a fault. If the bonding is compromised, the fault current might not be high enough to trip the breaker quickly, leading to prolonged exposure to dangerous voltages. Now let's focus on the equipment grounding conductor. Its bonding to the grounded service conductor serves a similar purpose, providing a return path for fault current from equipment enclosures and other metallic parts of the electrical system. When siding is installed over a weatherhead, it can disrupt this essential connection, particularly if the siding material is non-conductive. Non-conductive materials act as insulators, preventing the flow of fault current back to the source. This insulation creates a scenario where metallic parts can become energized without immediately tripping a circuit breaker, posing a shock hazard to anyone who comes into contact with those parts. To further illustrate the importance of proper grounding and bonding, consider a situation where a fault occurs in an appliance. If the appliance is properly grounded, the fault current will flow through the grounding conductor back to the service panel, immediately tripping the circuit breaker. However, if the grounding is compromised, a fault current may instead flow through the appliance's enclosure, energizing the metal parts. If someone then touches the appliance while in contact with the grounded surface, they could experience a severe electrical shock. Addressing the electrician's responsibility, it's crucial to understand that electrical work is not simply about making connections. It's about ensuring the safety of the entire electrical system. Even if the electrician didn't install the original rope service, they have a duty to identify and correct any potential hazards they encounter during their work. This responsibility is especially important when dealing with service entrances, as these are the points where the electrical system connects to the utility grid. A compromised service entrance can have far-reaching consequences for the safety of the entire building and its occupants. When an electrician encounters a situation where siding is covering a weatherhead, they should take several steps. Firstly, they should carefully inspect the installation to determine the extent of the problem. Secondly, they should document their findings with photographs and detailed notes. Thirdly, they should communicate their concerns to the homeowner in a clear and understandable manner. Fourthly, they should recommend a course of action to correct the problem, which may involve modifying the siding to allow for proper bonding. And finally, they should refuse to proceed with any further work until the problem is addressed. It's also important to note that the NEC is not the only standard that applies to electrical installations. Local building codes and utility regulations may also have requirements related to service entrances. An electrician should be familiar with all applicable codes and regulations in their area and ensure that their work complies with all of them. When dealing with older homes, it's common to encounter electrical systems that don't meet current code requirements. In these situations, it's important to take a comprehensive approach to upgrading the electrical system to ensure that it meets modern safety standards. This may involve replacing outdated wiring, upgrading the service panel, and installing ground fault circuit interrupters, GFCIs, in areas where they are required. Now let's consider the specific requirements for grounding and bonding in more detail. The NEC specifies the size and type of grounding conductors that must be used, depending on the size of the service entrance. It also specifies the methods for connecting grounding conductors to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The NEC also has specific requirements for the bonding of metallic parts of the electrical system. Bonding is the process of connecting metallic parts together to create a continuous electrical path. This path ensures that fault current can flow back to the service panel, tripping the circuit breaker and preventing electrical shock. Metallic parts that must be bonded include equipment enclosures, metal conduits, and metal water pipes. In addition to the NEC, there are other resources available to help electricians stay up to date on the latest electrical safety practices. These resources include trade associations, industry publications, and continuing education courses. By staying informed and following best practices, electricians can help to ensure the safety of electrical systems and protect people from electrical hazards. Another important aspect to consider is the role of inspections in ensuring electrical safety. Many jurisdictions require electrical inspections to be performed on new construction and renovations. These inspections are designed to verify that the electrical work complies with the NEC and other applicable codes. Electrical inspectors are trained to identify potential hazards and ensure that they are corrected before the electrical system is energized. If you are planning to have electrical work done in your home, it's important to hire a licensed and insured electrician. A licensed electrician has the training and experience necessary to perform electrical work safely and in compliance with code. An insured electrician has insurance coverage to protect you in case of accidents or damages. When hiring an electrician, be sure to ask for references and check their credentials. You can also check with your local building department to see if they have any complaints against the electrician. It's also a good idea to get multiple bids from different electricians before making a decision. Be sure to compare the bids carefully and ask the electricians to explain their proposed work in detail. Don't just choose the lowest bid. Choose an electrician who you trust and who has a proven track record of providing quality work. Once the electrical work is complete, be sure to get a copy of the inspection report. This report will verify that the work was done in compliance with code and that the electrical system is safe. Keep the inspection report in a safe place for your records. Electrical safety is everyone's responsibility. By taking the time to learn about electrical hazards and following safe practices, you can help to protect yourself and your family from electrical shock and fire. Remember, if you are not comfortable working with electricity, it's always best to hire a qualified electrician. Electricity is a powerful force, and it should be treated with respect. When examining existing electrical installations, particularly older ones, it's crucial to understand the potential for deterioration of materials. Wire insulation can become brittle and crack over time, exposing the conductors and creating a shock hazard. Connections can loosen, leading to arcing and overheating. Components can corrode, compromising their functionality and safety. A thorough inspection should include checking for these signs of deterioration and taking appropriate action to correct them. This may involve replacing damaged wiring, tightening loose connections, and replacing corroded components. In some cases, it may be necessary to replace the entire electrical system if it is too old or deteriorated to be safely repaired. When working with electrical equipment, it's important to use the right tools for the job. Using the wrong tools can damage the equipment and create a safety hazard. Always use insulated tools when working on energized circuits. Wear appropriate personal protective equipment, including safety glasses and gloves. Be sure to follow the manufacturer's instructions when using any electrical equipment. Before starting any electrical work, it's important to de-energize the circuit. This can be done by turning off the circuit breaker that supplies power to the circuit. Always test the circuit to make sure it is de-energized before touching any wires. Use a voltage tester to verify that there is no voltage present. Even if the circuit breaker is turned off, there may still be voltage present in the circuit if there is a backfeed from another source. Be sure to take precautions to prevent backfeeds before working on the circuit. If you are working on a circuit that supplies power to critical equipment, such as medical equipment or life support systems, it's important to take extra precautions to ensure that the power is not interrupted. This may involve using a temporary power source or working with a qualified electrician who has experience with critical equipment. When working with electrical panels, it's important to be aware of the potential hazards. Electrical panels can contain high voltages and currents, which can be lethal. Never touch any exposed wires or components inside an electrical panel. If you need to work inside an electrical panel, be sure to de-energize the panel first and follow all safety precautions. Keep the electrical panel clean and free of obstructions. Never store anything inside an electrical panel. If you notice any signs of damage or deterioration to an electrical panel, such as rust, corrosion, or loose wires, contact a qualified electrician to have it repaired. Electrical panels should be inspected regularly to ensure that they are in good condition and operating safely. When running new wiring, it's important to follow the NEC requirements for wire size, type, and installation methods. Use the correct wire size for the amount of current that the circuit will carry. Use the correct type of wire for the application. For example, use THHN wire for dry locations and UF wire for wet locations. Install the wiring according to the NEC requirements for spacing, support, and protection. Avoid running wiring through areas where it could be damaged, such as attics, basements, and crawl spaces. Protect the wiring from physical damage by using conduit or other protective measures. When making connections, use the correct type of connectors for the wire size and type. Make sure the connections are tight and secure. Avoid using wire nuts on solid wire. Use crimp connectors or other approved methods for connecting solid wire. Label all circuits clearly and accurately. Use a permanent marker or label maker to identify the circuits. This will help you to avoid accidentally disconnecting the wrong circuit in the future. Keep a copy of the electrical panel schedule in a safe place. This schedule will help you to identify the circuits in the panel and their corresponding loads. If you are planning to add new circuits to your electrical system, be sure to consult with a qualified electrician to determine the appropriate size and type of wiring and components to use. Adding too many circuits to an existing electrical system can overload the system and create a safety hazard. Overloading an electrical system can cause the wiring to overheat, which can lead to a fire. It can also cause the circuit breakers to trip frequently, which can be a nuisance. If you are experiencing frequent circuit breaker trips, it's important to investigate the cause and correct the problem. The problem could be an overloaded circuit, a short circuit, or a ground fault. A qualified electrician can help you to diagnose the problem and make the necessary repairs. When using extension cords, be sure to use the correct size and type for the application. Use heavy-duty extension cords for high-power appliances. Avoid using extension cords as a permanent wiring solution. If you need to run power to a location that is not readily accessible to an outlet, consider installing a new outlet instead of using an extension cord. Never run extension cords under rugs or furniture. This can trap heat and cause the cord to overheat, which can lead to a fire. Inspect extension cords regularly for damage. Replace any damaged extension cords immediately. When using power strips, be sure to use a power strip that is rated for the amount of power that the connected devices will draw. Avoid overloading power strips. Overloading a power strip can cause it to overheat, which can lead to a fire. Plug power strips directly into wall outlets. Avoid plugging power strips into other power strips. This can create a chain reaction that can overload the circuit and cause a fire. Unplug power strips when they are not in use. This will help to conserve energy and reduce the risk of fire. Electrical safety is a critical aspect of home ownership and maintenance. By understanding the NEC requirements, recognizing potential hazards, and following safe practices, homeowners can minimize the risk of electrical shock and fire. Regular inspections and maintenance by qualified electricians are essential to ensure the continued safety and reliability of electrical systems.